The hidden wonders of Mercury: life, glaciers, and a diamond core. For decades, Mercury has been one of the most misunderstood and overlooked planets in our solar system. Being the closest planet to the Sun, it's easy to assume that this small rocky world is nothing more than a scorched wasteland, a barren, lifeless rock broiled by solar radiation. Its proximity to the Sun not only makes it one of the hottest places in the solar system during the day, but also makes direct observation from Earth extremely difficult. But as we've learned from science time and again, the cosmos is full of surprises. A recent groundbreaking study has completely upended our understanding of Mercury by suggesting that this seemingly inhospitable world may possess something astonishing beneath its surface: salty glaciers that could provide a habitat for microbial extraterrestrial life. Mercury, a planet of extremes. Mercury is a world of contradictions. With a diameter of just 4,880 kilometers, it is the smallest planet in our solar system, even smaller than some of the moons of Jupiter and Saturn. But don't let size fool you. Mercury is also one of the densest planets, with a massive iron core that dominates its interior. This rocky world orbits a mere 58 million kilometers from the Sun. With no substantial atmosphere to shield it, Mercury's surface experiences some of the most extreme temperature fluctuations in the entire solar system. Temperatures soar to 430 degrees C, 806 degrees Fahrenheit on the sunlit side, and then plummet to -175 degrees C, -283 degrees Fahrenheit on the night side. It's hard to imagine life in such an environment. Yet, against all expectations, scientists have now discovered compelling evidence that Mercury harbors glacial structures, composed not of water ice in the traditional sense, but of salty, volatile-rich flows that might have persisted below the surface for over 1 billion years. The clues buried in MESSENGER's data. This breakthrough comes from data gathered by NASA's MESSENGER, Mercury Surface, Space Environment, Geochemistry, and Ranging spacecraft, which orbited Mercury from 2011 until its planned impact on the planet in 2015. During its mission, MESSENGER provided an unprecedented look at Mercury's geology, magnetic field, and chemical composition. One of the most surprising findings from the MESSENGER mission was the discovery of water ice in permanently shadowed craters near Mercury's poles. But beyond the ice, the spacecraft also revealed peculiar regions with high concentrations of volatile elements, like sodium, sulfur, and possibly even carbon-based compounds, and unusual landforms resembling pits and hollows, suggesting that some of these substances may have outgassed or sublimated over time. These volatile-rich areas, scientists now believe, are the remnants of ancient glaciers, formed from salt flows that once emerged from Mercury's interior. These flows would have trapped compounds such as water, carbon dioxide, and nitrogen, key ingredients for life as we know it. A tale of salty glaciers and subsurface habitats. The team led by planetary scientist Dr. Alexis Rodriguez suggests that these glacial structures were formed when asteroid impacts exposed buried volatile layers, releasing their contents to the surface, where they were formed into salty, frozen flows. Unlike Earth's glaciers, which are mostly composed of water ice, the glaciers on Mercury are thought to be dominated by salt compounds, which have unique properties that allow them to preserve water and other volatiles even in extreme environments. Rodriguez explained the importance of this discovery by comparing it to similar phenomena here on Earth. In places like the Atacama Desert in Chile, one of the driest and harshest environments on our planet, life exists only because of specific salt compounds that trap moisture and create microhabitats for extremophiles. This has led to the tantalizing idea that similar microscopic life forms could theoretically survive on Mercury, hidden beneath its blistering surface in protective pockets of saline ice. From salty glaciers to sparkling diamonds. While the discovery of potential life-supporting environments is stunning, it is not the only jaw-dropping revelation about Mercury. Scientists also believe that the planet might harbor a thick layer of diamond deep beneath its crust, possibly up to 18 kilometers thick. This idea stems from Mercury's unusually high carbon content, particularly in the form of graphite in its crust and mantle. Using high-pressure experiments, researchers found that with enough pressure and the right chemical ingredients, especially sulfur, which is abundant on Mercury. Graphite could be compressed into diamond. During Mercury's early formation, the planet likely had a magma ocean. At the boundary between the molten mantle and the cooling core, the conditions could have been just right to create a diamond factory. Since diamond is lighter than molten metal, the crystals would have risen and accumulated at the core mantle boundary, creating an enormous, hidden layer of diamond over time. Although these diamonds would be buried more than 600 kilometers below the surface, well beyond the reach of current detection methods, scientists hope that some surface activity, such as ancient volcanism or massive impacts, may have brought small quantities of diamond to the surface. The high magnesium province on Mercury is considered a potential location for such a find. What comes next? Bepi-Colombo's promising future. To further explore Mercury's mysteries, the Bepi-Colombo mission, a joint effort between the European Space Agency, ESA, and the Japanese Aerospace Exploration Agency, JAXA, is en route. Launched in 2018, it has already completed several flybys and is set to enter orbit around Mercury in November 2026. This dual-orbiter mission is equipped with state-of-the-art instruments that will allow scientists to probe Mercury's surface and subsurface in more detail than ever before. If the existence of salt glaciers and diamonds is confirmed, it will completely transform our understanding of the planet and its potential to host life. Mercury reimagined. So what does all of this mean for astrobiology and the broader search for life in the universe? Quite a lot. Mercury was once considered the last place in the solar system to host life. But the presence of ancient, volatile-rich salt glaciers, hidden beneath a crust potentially laced with diamonds, changes the game. It suggests that even the most extreme planetary environments may harbor pockets of habitability, expanding our definition of what a habitable zone really is. As Dr. Rodriguez noted, this makes us wonder if there are subsurface terrains on Mercury that might be more hospitable than its harsh surface. That wonder, that curiosity, is what continues to drive exploration and discovery. And who knows, perhaps Mercury, the planet once dismissed as a lifeless rock, will turn out to be one of the most surprising keys in our search for life beyond Earth.